Hey everybody, how's it going? My name is Remy, and in this video I want to address a big problem that I see in today's trend, which is that while a lot of people are curious about programming and want to give it a go, most just don't know where to begin. They might be asking themselves questions like, which language should I learn first? Or jump straight into complicated tutorials on topics that they may or may not find confusing. Now, while that may work for some people, for absolute beginners who've had no previous exposure to the field, that is not the best way to go. Now, a great man once said, you can never learn how to program by watching a programming tutorial. So let me show you a better way. Now, I want you to pick a programming language, any language. Do you have one? Good. And just keep that language in mind. And let me tell you a little story from this movie I like called The Pursuit of Happiness. Now, in this movie, there's a particularly good scene where Will Smith goes in for a job interview and stands before a bunch of executives. And it's clear right from the get-go that he hasn't got the first clue what they do there, what the business is really about. But it says something brilliant that turns the scales in his favor. It says this: well, look, I'm the type of guy who, if you ask me a question and I don't know the answer, I'm gonna tell you that I don't know. I bet you what, I know how to find the answer, and I will find the answer. Just consider this for a second. Knowing how to find the answer is infinitely more valuable a skill than actually just knowing the answer outright. With that in mind, let me share with you the secret weapon, the most valuable skill that any programmer can have in their arsenal, which is the ability to Google things and to find answers to your queries. Now, do you remember that programming language you had in mind? Well, the first task of the day is going to be to go ahead and Google how to install that language on your computer. I'm going to give you a little recommendation regarding how to get the best out of this video. I'm going to be going through all of my examples today using Python, and you're welcome to follow me along using Python as well. However, once you're done, go ahead and watch this video again, but this time choose another programming language and follow through those same examples in your programming language of choice. It's going to involve a lot of Googling things to find out how to make my examples work in your programming language. But I promise you, you're going to come out of this on the other end having immensely improved this invaluable skill of being able to Google things and search for answers. So, the first task of the day, as I said, is now going to be to install Python on your machine. So go ahead and Google how to install Python on my computer, assuming you don't already have it installed. Now, for the lazy ones of you out there who don't want to do the work themselves, I've left a helpful link down in the description below. Feel free to make use of it. All right, past this point of this video, I'm going to assume that you've got Python installed on your machine, and let's jump straight into it. All right, guys, let's write our first line of code. Now, our first program will be to simply take some text and output it out to the console. So let's have a Visual Studio Code open right here. If you don't already have one, I highly recommend it. It's a great text editor. Go ahead and install it. And we'll just create a new file and we'll call it hello world.py. .py is an extension for Python files, and is going to be what we're going to be using today. All right, once you have your Python file open, all you need to do is type print, and in brackets and parentheses type hello world. Then go ahead and save this by pressing Ctrl S. And then to run this file, all you've got to do is to navigate into the folder in which you have this file. So for example, I have it in a folder on my desktop called 1, and there it is, as you can see. And all you have to do is to type Python3 and the name of your file, hello world.py. And once you run it, as you can see, it's outputted hello world out to the console. So this is the simplest program that you can imaginable that you can write, and is a good introduction for many programming languages. What you've just done is you've just told the computer to print text out to the console. and it's done that, which means that you can change this to my name, say hello Remy, and you can go ahead and print that, and it's gonna say hello Remy, or anything you like. So that is the beginning. Let me introduce you to the next concept, which is called variables. Now with variables, what you can do instead of spitting out a solo line of text to the console, you can say a variable called phrase, which is the name of the variable, can be anything, and that is going to be equal to, and we'll say this is equal to hello world. So the same thing, but instead of writing hello world out over here, you can instead print out phrase. Now the reason why this is more efficient than doing it the old way is because you can now reuse phrase in various parts of your code. You don't have to type hello world ever again, you just use phrase. And you can imagine how useful this could be when when the actual data of your variables is going to be fairly large, such as a collection of objects. So now let's just run this, and you can see it prints hello world. And if we just say hello and then name or define another variable, and this variable is going to be called name, and we'll say its name is Remy, the value of this variable is Remy, and you can go ahead and you can do phrase and name, so you can print two different variables in sequence. Now if you run this program, as you can see, now it says hello Remy. Alright, now the next concept I'm going to show you are the conditionals. It'd be really boring if the only thing you can do is just this without having the computer make its own decisions based on the value of some previous variable or input. So let's write a conditional. So first of all, let's define a situation in which we'd need one. Say for example, a phrase would be a personalized welcome message for a person named Remy and a person named Jack. So we'll call phrase 1, which is going to be a personalized message for Remy, and Remy will want to hear, "Hola Remy, how's it going?" So this is the personalized message for Remy. I'll just copy and paste this and create another variable, and we'll call this variable phrase 2, and this variable is a personalized message for a person named Jack, and it's gonna be, "Hey Jack, what's up?" Alright, these are two personalized messages based on the value of the name. So what we want to do is, if the name is equals to Remy, we want to print the personalized message for Remy. Whereas if the name is equal to, say, Jack, we'd want to print a personalized message for Jack. And so let's implement this. Let's go ahead and type so if, that is the key word for a conditional. So if, and we check if the name is equals to Remy with a capital, and the double equal sign means that it's comparing the value of the variable name to this value that you're giving it to compare to. So a single equal sign is an assignment. So you're saying that phrase 1 is actually equal to this. It's a statement, which means that you're setting phrase 1, the variable, to be equal to this value. Whereas a double equal sign means that you're comparing it. So is this actually equals to Remy? If yes, then we're gonna go ahead and execute something that's gonna be in this block. And what we wanna do here is we wanna print out the personalized phrase for Remy. So that was phrase 1. And then, so if it is, we're gonna print phrase 1, but if it's not, then we're gonna check. So elif, that means else if in Python, name is equal to the value of Jack. Then what we're gonna do is we're gonna print out the personalized message for Jack. So phrase 2 was the personalized message for Jack. I'm gonna go and save that, and we'll run this program and see what happens. So Python 3 hello world.py, and we've got an error on line 10. Why is there an error? Name phrase is not defined. That's right, because I've left this line without deleting it first, and we no longer have a variable called phrase because I've redefined it to phrase 1 and phrase 2, which is why it was throwing me an error. So let's go ahead and delete this line. We don't need it anymore. And save the file. Let's run it again. And we've got a personalized message for Jack saying, "Hey Jack, what's up?" Now, why did we get the personalized message for Jack? Well, because the name is equal to Jack. Now, if we were to say the name is equal to Remy, what do you think is going to happen? That's right. It's going to give you the personalized message for Remy, which is, hola Remy, how's it going? Now, what do you think will happen if I change the name to something like Howard? Now, that is neither Remy nor Jack. What do you think will happen if I run this program right now? What's going to be the output? Just take a second to think about it, and let's run it and see what's actually going to happen. Nothing. Nothing happened. There's no output. Now, why would that be? Now, let's just go through the program line by line and see exactly what it's doing. So, if name equals to Remy, so is the name equal to Remy? No, the name is equal to Howard. Okay, then we don't execute this line here. Now, else if, is the name equal to Jack? No, it's Howard. Then we don't execute this line here. So we don't do neither this nor that, and then we keep going, and there are no more lines of code to execute. So the program terminates, and we don't get any output. So to mitigate this, because the name could be anything, we'll just go and define a final condition, which means else. So if the name is literally anything else other than the first two values, then we execute whatever's in this block, and we'll just say print, and we go hello stranger, because we don't know who they are. So now we run this program, the name is equal to Howard, and we get hello stranger because it executes neither this nor that, but the final line. And of course we can, instead of stranger, because we know that the name is equal to Howard, what we can do is we can say hello, and then we can say name. So we can print out a line of text, which is a string. It's called lines of text in programming are called strings. So this is a string, and this is a variable, which is also a string. So now we do this, and we get a personalized message for Howard. Hello, Howard. And if this was equal to, say, Sheldon, then we'd get the personalized message for Sheldon. Hello, Sheldon, because it's just printing out whatever the name is. All right. Now let me show you the loops. Now a loop is basically a way for your program to execute multiple times the same line or block of code. For example, if you wanted to print hello Sheldon, in this case hello name, 50 times, we wouldn't just copy and paste this like this and just go 1, 2, 3, 4, 5, 6. It would be very inefficient to do this. So this is not what we're gonna do. What we're gonna do is we're basically gonna define a loop here. So to define a loop, we're gonna say for is the key value for the loop, and then we're gonna say I, which is a variable that's gonna measure the times that the loop has actually run. Let's say in range, and the range is gonna be 0 to however many number you wanna run it, and the final number is not inclusive. So we'll say 0 to 50, which in reality means that it's gonna run it to 0 to 49 times. And then inside of this, we're gonna go ahead and we're gonna move this line into the block. So indent it like this, so that it's part of this loop. And now once we run it, it's gonna print out hello Sheldon 50 times. I'm not gonna count each one, but you can basically trust that it's gonna be 50 times. And to verify, you can actually print out the I. So I defines the value. I defines the number of the times that the loop has actually run, and is an integer. So if we go ahead and print I alongside our phrase, we're gonna see the counter. So we can see it goes from 0 to 49 times. Now this is not the most practical application of it, but it is an application. So another way to do this would be to there's another loop called the while loop, which basically if you go while true, and then anything inside of this loop is gonna run on repeat over and over and over again until you stop it. And to stop it, you would define break in one of the conditions, or just in general. So let's run this and see what happens. And of course nothing is happening because the name is Sheldon. It's gonna break it right away. However, if the name was Remy and we go ahead and run it, it's going to run forever and never stop, because we don't have a break condition anywhere. It is an else, but the else is never executed because the first line is always executed. So how do we actually let's start a useful application for this. One useful application would be to create user inputs. Now it'd be really, really boring if we always have to change the name inside of the program to actually define what it is. Sometimes you want the user to give you the input such as the name, and then do upon it what we will based on the user input. So in order to do this, all we're gonna do is we're gonna print out just a prompt, simple prompt, say enter name, and then instead of defining the name as Remy right away, what we can do is we can say name is equal to input, like this. And this will basically mean that the name will be whatever the user gives it. And let me show you how this works. So we're gonna cut this and we're gonna paste this into the loop. So the name is equal to input, and now, as you can see, let's just bring back what there was before. So for example, hello plus name, just so we can clearly visually illustrate what it's doing. So we're gonna run this program now, and it says enter name. So we're gonna say the name is Remy. You can see it gives me the personal message for Remy, and then it goes back over to the first line inside the loop, which is this one, and it's gonna do the same thing again, enter name, and it's gonna do it over and over and over again without ever terminating. So if I say the name is Sheldon, it's gonna say hello Sheldon, and then it's gonna ask me again. So how do we terminate this? To terminate this, we need that little break keyword, as I showed you before, somewhere in here. So for example, let's say the keyword to terminate this loop would be Q for quit. So we would add another conditional check, and we'll say else if, and here we're gonna say if name is what the user enters, and it's gonna be equal to Q, which stands for quitting, then we're gonna break this loop and end it. Otherwise, we're gonna just keep going forever. So as you can see, we go Jack, what's up? It's gonna keep going forever until you type in Q, bam, it finishes. Because it checked this condition, is the name equal to Q? Well, yes, it actually is. What do? We break the loop and we end it. So that's it for loops. Now, in the next section, we're going to write a program that is going to take all of this logical construct that you just learned and put them together in some useful way. All right, let's write a program. What we're going to do is first we're going to delete all of this here, which we've done before. We're not going to be needing it. And the program we're going to write is going to be a program that takes as an input a collection of elements, so a collection of numbers, for example, integers, and they're not going to be in any order, so they're going to be unordered. And our program's goal will be to sort it in ascending order and output this sorted collection of elements. Now, this collection of elements is going to be called an array. So let's define an array as a collection of elements. So, for example, an array is the name of the variable, and to define the collection of elements, we'll open square brackets like this, and then we'll give it numbers, just random 4, 8, 1, 5, 3, 7, 9, 1, 2. As you can see, it's not in any particular order. So this is our collection of elements. Now, our goal here is to take these elements and sort them. Now let me show you some characteristics of the array. For example, if you wanted to print out an array, let us see what happens if you print an array, what the output is actually going to be. We're going to run this, and as you can see, it just prints out exactly what is here. However, what if you wanted to print out a specific element of the array? For example, we were looking for the number 5. Number 5, so to do this, we'll just count the positions. So the indexing positions of the array always start at 0. So we go 0, 1, 2, 3. So number 5 is actually in the position 3 of the array. So in order to print this, we're going to open up these square brackets, and we're going to say the position 3 of the array. And if we print this, it's going to give us the actual number, which is 5. And if we were to print, for example, the position 1, what do you think that's going to be? Is it going to be 4 or is it going to be 8? As you have probably guessed, it will be 8 because 4 is at the position 0 of the array. Another thing we can do with arrays is we can find out how many total elements there are. So for example, we go length and of what? Length of what? Of the array. And then we're gonna print it out, and we can see there's a total of 9 elements starting from 0, starting total. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is correct. So in order to be able to sort this, using bubble sort, we'll need to iterate through the array in some way. Let me just explain verbally how bubble sort works. Bubble sort will take the first element of the array and it's going to compare it to the second element of the array. And it's going to check, is 4 actually greater than 8? Well, no, 4 is not greater than 8, so we'll leave it what it is. Now, it's going to go to the second element of the array and it's going to check, is 8 greater than the next element in the array, which in this case is 1? Well, yes, 8 is greater. So what's going to happen is we are going to swap them around. Now 1 is in place of 8 and 8 is in place of 1. Now is 8 greater than 5? Yes, it is. So same thing, we'll swap them around. As you can probably see, 8 is going to travel all the way here to where 9 is. When it's going to check, is 8 greater than 9? It's not, so 8 is going to stay where it is. And we'll jump onto 9 and we're going to check, is 9 greater than 1? Yes, it is. And 9 is going to travel all the way to the end where it's going to stay. And then we're going to start again from the next element and we're going to check again. And as you can see in this way, all of the large elements will end up traveling all the way to the end of the line. And the smaller elements will be pushed up to the front. And that's how we'll get a sorted element. So first we need to iterate through the array using a loop because we're going to run the same thing over and over again but with different element. So how we do this is we're going to say for, as we've known to be our keyword for the loop, and we'll say I in range, and the range we want it to be 0 to the length of the array. As we know, the length of the array is not inclusive, so the length of the array is 9, but the maximum position of the array is actually 8. So this is alright because we don't need to include 9. So it's just going to run it all the way to 8 because the last element of the array is in the position 8. So for I in the range of this, and then we're going to define another loop. So we got j in range, and we're going to say, so it's going to always start to the element that is adjacent to I. So I is going to be the first element, and then eventually the second and the third. J, the second iteration, the one we're comparing it to, is always going to plus 1. So this is the beginning of our range. And the end of our range is going to be the length of the array, likewise. And then we're going to open this and we'll do the swapping operation inside of this block. So how to do swapping operations? So for example, we'll check, is the element at the position I greater than the element at the position j? And the way to do this is we go, so we're going to say, if array, so if the element at the position I is greater than the element of the position j, what we need to do is we need to swap them around. Otherwise we wouldn't have to swap them around. And the way to do this will be to first define a temporary element and give this temporary element the value of the element at the position I of the array. And the reason we do this is because if we were to just say array, so the element in the position array is equal to the array in the position j, because we'll also need to say that j is equal to I, but we won't have I anymore because we've just defined I as j. So then I would be lost, which means that we need to define a temporary placeholder element and define it as I, and then go ahead and redefine I as j. So we'll redefine I as j, and then we're gonna redefine j as I. So array at j is equal to, what's that equal to? Is it equal to array I? Well, no, because array I is actually now equal to array j. So array I is no longer available. So temp is available, and temp was defined as array I before, so we're gonna say temp. And that's it. And this is just going to basically do what I've told you before, and it's going to sort the entire array. And just to verify, we can go ahead and print it out and see our result. Let's go ahead and run the program. As you can see, we've actually sorted the array. 1, 1, 2, 3, 4, 5, 7, 8, 9. Now, if you wanted to have it in a descending order instead of ascending order, it'd be the simplest thing in the world. All we have to do is change the comparison sign. So instead of checking if the position on the left is greater than the position on the right and swapping it in that case, we would check the opposite. We'll check, is the position on the left less than the position on the right? And if it is, then we would swap. And then if you run this, we have our same array in descending order. Alright guys, thanks for watching. I hope you've got your money's worth out of this video. The one thing I especially hope you take away from it is that knowing how to Google things is extremely important, and there's no shame in Googling even the most basic things. I plan to do a series of other tutorials from the most basic to the most advanced, so make sure to subscribe so that you don't miss out. And hit the like button, that's gonna help me out a lot. And see you in the next one.